In this video, we're going to create equivalent inequalities with construction webs using a variable. So let's read the directions. Complete the construction web by starting with the inequality x is greater than 6 and performing the indicated operations on the inequality moving outward. Then complete the table below, which is below on your packet and on our next slide. So, first, starting with x is greater than 6, our first operations are with -3. So we're subtracting left-hand side x minus -3, right-hand side 6 minus -3. Okay. And we subtracted, so we don't have to reverse the direction. We have x plus 3 is greater than 6 plus 3, which is 9. Here, we're adding -3 to both sides. So we have x plus -3 on the left and 6 plus -3 on the right. So x plus -3 is the same as x minus 3. And on the right, we have 6 plus -3 is 3. Moving on to multiplication, we're going to multiply both sides by -3. -3 times x and -3 times 6. And since it's multiplication by a negative, we need to reverse this sign. So -3x is less than -18. The next one is division. So we have x divided by -3 on the left, 6 divided by -3 on the right, and we need to reverse the direction because we divided by a negative. So we'll write this as -x over 3 is less than 6 divided by -3 is -2. Now let's move to the second operations. We're asked to perform these operations with 2. Since 2 is positive, we don't have to worry about reversing any of the directions. So left-hand side, we are dividing. X plus 3 divided by 2 is the left, and on the right we have 9 over 2. And there's nothing really to simplify there. And the inequality is greater than 9/2. Moving to this side, we want to multiply by 2. So on the left we have 2 times x minus 3. On the right we have 2 times 3. We don't have to change the direction. Okay, and we could distribute, but I'm not going to. We're not solving yet, and this is a good structure. So greater than 2 times 3 is 6. Now here we're going to subtract 2 from both sides. So -3x minus 2 and -18 minus 2. So our inequality is -3x minus 2 is less than -20. And finally, we are going to add 2 to both sides. So we have -x over 3. I'm going to add 2 less than -2 plus 2 is 0. And we have completed the web. So now all of these inequalities are equivalent inequalities, just like we built up equivalent equations before. So the result for any of these would give a final solution if we were to solve them, which we'll do later, of x needs to be strictly greater than 6. Okay. Now we just want to look at, when we worked with equations, we plugged our value for x back in to check that the equation was true and that the equations were equivalent. Now here, with inequalities, remember there's infinitely many solutions. So instead, we're just going to pick a test value. So it's always good to pick a test value for an inequality to check your work. So unlike with the equation, it doesn't guarantee your work, but typically the error you make is not reversing the sign. So this will just give you a good idea. It's not definite proof that you did everything right, but it may catch the most likely thing you'll do wrong. Okay. Now my favorite test value, so our original inequality was x is greater than 6. My favorite test value is 0. And this is because when you compute with 0, it's easy to add 0, and it's easy to multiply by 0. Okay, so we need to write the corresponding truth value, though. Okay, so is 0 greater than 6? The answer is no. So the corresponding truth value is false. You should write false. Okay. So now what I'm going to do is I'm going to evaluate the left-hand side with a test value of 0, okay? And it should give me all false inequalities when I'm done. And that would mean that the truth value of the test value corresponds to the truth value of the original inequality. Remember, not a guarantee, but it's a good check. So on the left-hand side, 0 plus 3 equals 3. And is 3 greater than 9? And it is not. So this is false. Okay. And does the truth value of the test value correspond to the truth value of the original inequality? And it does. Left-hand side here, 0 minus 3 equals negative 3. Is negative 3 greater than 3? I'm taking the 3 from there. And no, it is not. That is false. So that corresponds. Okay. Here on the left-hand side, we have negative 3 times 0 is 0. And we ask, is 0, is that less than negative 18? And it is not. This is another nice reason. So here, it's easy to compare positive and negative numbers to 0. Negative 18 is negative, so it's less than 0. So this is false. So it corresponds. Here we have 0 over negative 3, which is 0. I want to know, is 0 less than negative 2? And no, it is not. Okay. So far I haven't caught any errors. Again, it doesn't guarantee I was correct, but it's a good indicator that I probably did okay and that the direction of my inequality symbols are okay. Now we have 0 plus 3 over 2, well, that is equal to 3 halves. Now we want to know, is 3 halves greater than 9 halves? And this is 3 copies of 1 half. That is not greater than 9 copies of 1 half. So this is false, and they're corresponding. Here we have 2 times 0 minus 3. Well, that's 2 times negative 3, which is negative 6. And our question is negative 6 greater than 6? And no, it is not. Positives are greater than negatives. And now here we have negative 3 times 0 minus 2. Well, this is just 0. 0 minus 2 is negative 2. And our question is, negative 2, is that less than negative 20? And it is not. It is greater than negative 20. And finally, replacing x with 0 here. 0 over negative 3 plus 2. Well, that equals 2. Is 2 less than 0? No, it is not. So the truth value corresponds. Okay? So again, not conclusive proof, but using the idea of a test value is going to help us in many ways later for not only attempting to verify or just doing a quick check that's not conclusive, but it's a good indicator of whether you solve the inequality right, and also for determining which direction we're going to graph in when we start graphing inequalities.